Welcome to the second part of this video tutorial. My name is Gianluca Bertelli, and in this video I would like to show you how to create a Windows Store application that uses Facebook as login provider. What we are going to create is a simple application that asks to the user to log in with Facebook and then access his personal information. But let's start from the result. Okay. The first time I launched the application, I'm an anonymous user. What I need to do is to click on the login button and the Facebook login page is displayed. I have to fill the text boxes with my personal account's information and click on login. What we are seeing right now is Facebook that is asking us to grant the permission to this application. I trust this application and therefore I click OK. As you can see, this is a really simple application. It's just trying to download the picture profile of the user. In the next video, you will learn how to enhance this application and how to use the Facebook APIs. But for this part, we are focusing on the login part. This application implements a sort of single sign-on. If I close it and relaunch it, you will see that I'm still logged in. This behavior is not coming for free. We need to code it. It's not really complex, but before to show you the code, I need to explain a little bit more on the background. So let's move to PowerPoint for a little bit of theory. Generally speaking, there are many ways to authenticate the current user. For example, we can leverage the Microsoft account that has been used to log into the device, or if the device is domain joined, we can use the standard Windows authentication. Another option is to create our own authentication method, but in this case we have also to maintain a backend server to store the user accounts. This kind of approach is not only more complex, but typically annoys the user that have also to register with our service. In this video, we will focus on the last point, how to authenticate the user with a third-party authentication provider, or better, how to authenticate the user using the OAuth 2 protocol. This protocol is an open standard that is used by the majority of social networks. It's not really complex. It's based on HTTP calls and redirection, but we need to be aware of some key points. First, only the authentication provider knows the username and password, and only it can grant the permission to access the user information. This is why, for example, you see the login page during this process. The second concept is the token, that is the result of correct authentication. The token is like a password, but gives us a temporary access to the HTTP APIs of the provider. Remember that until the token is valid, we act on behalf of the user. Let's see a very simple flow. Starting from our application, we call the authentication provider at the specific URL. This triggers the login process. The provider will redirect us to its login page that is nothing more than a standard HTML page asking for user credential. If the user is authenticated successfully, the provider will answer with a success code and attach the token to the response. Because this protocol is a standard, we don't need to know all the implementation details, but we can simply use an helper class that do the work for us. This class is called Web Authentication Broker. Okay, now that we know how does it work the protocol, let's see a real example using Facebook. In the previous video, you learned how to associate a Windows Store application with a Facebook application. What we need here are the Facebook client ID and the Windows Store app ID. We need these values just to create the login URL for Facebook. This URL is what we need to pass to the authenticate async method. As you can see, it's really simple to trigger this process because we just have one entry point, one single method to call. Calling this method will cause the broker to pause our current application and display the Facebook login page in a full screen. If the user inserts the correct credential, the broker will return us with the authentication token in the response data field. Otherwise, an error code is returned. Once we have the token, we can read the user profile and impersonate the user. One of the main advantages of the Web Authentication Broker is that provide a secure execution environment. The calling application, for example, will never be able to access to the user credential. This is because the user interface that is displayed is not part of the store application, but is a different process running in a different app container. So the end user can safely insert the user account without worrying about if the calling application will store the credential or not, because this is not possible. On the other hand, my suggestion is to do not trust the application that do not leverage the Web Authentication Broker. Why? Because you are giving them your credential in a clear text. Okay, now that we learned the theory, let's move to Visual Studio. I started from the blank template in Visual Studio 2013. I created a simple XAML page with two buttons, one for the login and one for the logout. I also added an image control to display the profile picture. To separate the code from the UI, I created an helper class that I called Facebook Helper. Let's zoom it a little bit. In this class, I added three methods, one for the login, one for the logout, and one to get the profile picture. The login and logout methods are bounded to the button in the main page. Let's start coding the login method. In this moment, this method does nothing. It's simply set to false. The properties is logged in. So if I launch the application and click on the login button, nothing happens. If you look at the Facebook documentation, you will find how to create the login URL. This login URL has to follow a specific pattern. For example, we need to set the client ID field with our Facebook app ID, and we need to set the redirect URI field with our Windows Store app ID. This is why I already created these two strings. Once we have created the login URL, we can trigger the authentication process. To trigger this process, we just need to write one single code. Web authentication result, auth result, await web authentication broker dot authenticate async. If you remember, I told you that we have two overloads for this method. The first overload takes two parameters and the second one takes three parameters. Because we are going to create a single sign-on version of this application, I'm going to use the overloads with two parameters. The first parameter is web authentication option .known, and the second one is the login URL. Once we have triggered the login process, we just need to check the result. So let's check if the user has logged in or not. The response status field tells me if the process have been completed successfully or not. Success. If so, I set is logged in to true. Now set a couple of breakpoints and run the application. Click on login. OK. As you can see, the login has right now all the specific information for our application. And calling this single line of code is what triggered the authentication process. F10. Okay. The broker has jumped in and is asking for credential. If I log in and if I authorize this application, the response status is success. This means that the user has been logged in Facebook and has granted the permission to our application. My code simply downloads the profile picture once the user is logged in. Now that the user has been authenticated, we can retrieve the token. The token is returned in a URI format. Therefore, we need to do a little bit of work before to access it. Call back URI, call new URI, auth result.response data. Response data contains the response from Facebook. Token equal. I created a small method to read the response from Facebook and to get only the token. Callback URI. This method is really simple. It just search for the term access token and return the substring. Let's put a breakpoint here and run the application. Click on login and authorize. Okay, here we are. The callback URI does not only contains our access token, but it contains also the Windows Store App ID. With this simple method, we are just reading the token. This token is what we need to access to Facebook API. Therefore, right now the user is logged in and we can act on behalf of the user. But what is the problem with this application? If I close the application and run it again, I'm anonymous. This is different from what you saw at the beginning of this video. This is because even if we retrieve the token, we are not reusing it. To reuse the token, there are many options, but I would like to show you the best way. So let's go back to a PowerPoint for a couple of slides. Now that we know how to leverage an auth2 provider for authentication, we can introduce the single sign-on. Generally speaking, we have a single sign-on when the user is able to log in on multiple different applications, inserted the credential only once. Authenticate Async has two overloads, one with 2 parameters and one with 3 parameters. The main difference is that the version with 2 parameters persists the session cookies. For example, using this overload, we allow the user to select the Keep Me Logged In option in the Facebook page. But remember that even using this option, the broker UI is still displayed. This is because even though the user has been authenticated, he needs to confirm the app authorization. This is part of the auth2 protocol. That being said, we can completely avoid to show the login UI only if we have a valid token from the previous session. This works because the token that we receive from Facebook is not related to a single session, but has an expiration date, and we can use it until it's valid. For example, we can persist the token in the device and use it across multiple user sessions. Let's see how we can use it. The token is just a string, so we can save it everywhere, locally or remotely. But because it's a sort of a password, it should be placed in a secure location. Windows and Windows Phone 2 have a built-in and high secure password vault. We can use this secure storage to save our tokens. Its usage is really simple. You can think about it like a classic dictionary. Therefore, we have a single method to add an item to the collection and a single method to retrieve an item back. The first advantage of this approach is that we don't need to think about the security, because this vault stores the information in an encrypted way, and only the real user can see the information in clear text. The second advantage is that the stored credential roams with the user account. Therefore, if the user has multiple devices, our application needs to be authenticated only on one device. Let's implement this in our demo. The first step to reuse our token is to create our password vault object. I also created two strings. These strings are needed to identify this application in this collection. When the user is logged in successfully, we can store the token in this password vault. It's really simple. Vault.add and create a new password credential object. My application name, my key for the dictionary, and the token. Good. Now, if the user asks to be logged off, we need to clear this entry from the password vault. So, vault.remove, and we need to pass the same object or create a new one with the same parameters. App name, key token, token. Let's see in action. Start application and login. Now that I'm logged in, the token has been stored to the password vault. How can I check if the token has been saved correctly? In Windows, there is an applet in Control Panel called Credential Manager. The Credential Manager is nothing more than the list that is used to store these passwords. If I look at this list, I find my entry. My Facebook is my application. Facebook token is the key that I provide. And the token that I store is saved in the password field. As you can see, I need to insert the password to see the clear text, because this token is being saved in an encrypted way. Now, if I ask to be logged out, and check back in this collection, F5 just to refresh, you can see that the entry has been removed correctly. Now that we stored the token, if the user logs in correctly in Facebook, we can optimize this application. As an optimization, we can avoid to ask to log in every time the user opens our application. If the user has been already logged in, we can retrieve the token from the previous version. To do that, we need to create a new method in our helper class. With this simple method, login with cached credential async, I'm just trying to check if a token exists or not. If it does exist, I set to true is logged in. What I have to do is to call this method in the allloaded event for this page. I also want a flag, just to check if the user has been logged in automatically or not. BSuccess equal await Facebook helper dot login with cached credential. If BSuccess, then await update profile picture. Now set a breakpoint here at the beginning of this method and launch the application. Okay, BSuccess is false. This is because it's the first time we launch this application. If I click on login and authorize this application, the token is stored in our password vault. This means that if I close the application and start it again, our method will find the token in the password vault and will reuse this token to log me in. As you can see, I've not been asked for credential anymore, even if I close the application and restart it. So we are done. We reached our goal of a single sign-on application using Facebook as a login provider. I hope you enjoyed this short video and I want to wish you happy coding.